Okay, here's example number 8. Very similar to this problem, we've got two logs, same base. This is a log base 3, and we're subtracting the 2. Immediately you should be thinking, okay, that's our subtraction rule. I'm basically going to combine this into a single log 3 where the 2x minus 1 is being divided by the x minus 4. So, perfectly right, first step, log base 3, 2x minus 1, all over x minus 4, still equal to 2. Okay? Pretty straightforward. Again, just like in example number 7, we're going to now convert this to an exponential equation. We've got it down to 1 log, now convert it to its exponential form, and that's a common theme in solving logarithmic problems. So this just says, oh, 3 to the second power is this, so we'll just write this. 2x minus 1 over x minus 4 is 3 to the second power. Of course, 3 to the second power is 9. Okay? Now notice, no exponents, no logs. We're free to figure out how to solve this thing as best as possible. We've got this big ugly fraction. I'm going to multiply both sides by x minus 4. Okay, these things are now going to cancel out. But of course I got to do x minus 4 over here. So after we cancel out, we're going to have 2x minus 1. Those cancel. 9x minus 36. If I distribute. Going to do maybe a couple steps here. I'm going to subtract the 2x from the 9x. Take it away from this side. Drop this side to a 7x. Going to add the 36 to a negative 1 and get 35. Okay. Now I got all my variables here, all my constant terms here. Just going to divide by 7. 5 is equal to x. How cool is that? We only got one answer this time. We didn't have to do a quadratic thing at all. We got one answer. It's positive. We should feel pretty good about it. Always good to check anyway, so I'm just going to run over here. We're going to put 5 in for x. Okay? And we'll try to run through this as quickly as possible. We're going to have the log base 3. And if I put a 5 in for x, 5 times 2 is 10. And 10 minus 1 is 9. So this is log base 3 of 9 minus log base 3 of 5 minus 1, or 5 minus 4 is 1, right? So that's just the log base 3 of 1. Okay? And we're hoping all this equals 2 when we're done, right? Well, these are pretty straightforward problems. We know that what do I put on a 3 to get a 9? I put a 2. What do I put on a 3 as an exponent to get a 1? Obviously a 0. And 2 minus 0 is 2. So this is declared true. And that's example number 8. That's 8 different examples, different types of logarithmic equations, different techniques and styles for solving them. And we'll work some more in class and become experts at logs.